So, good evening. Well, welcome to the Royal Society's third in the Science Matter series here at the Royal Festival Hall on London's South Bank. Now, tonight we're discussing machine learning and artificial intelligence and the way in which they are already shaping the world around us, as well as discussing how they might transform our future. Artificial intelligence, that's a term that we are all probably aware of, usually, I think, via science fiction. So we tend to think of things like HAL in 2001, or Deckard in Blade Runner, Skynet, Terminator, which certainly gives us, probably in popular culture at least, a rather bleak outlook about the future of artificial intelligence. So tonight is really about the scientific reality. Now, a lot of the current advances in AI have been made possible in a scientific field called machine learning, which is one of the key things we're going to discuss tonight. It's grown rapidly in recent years, and there are many applications. You're probably familiar with them, although you might not know it. So Google Search, for example, uses machine learning. Spam filtering on email, Netflix film recommendations, Facebook feeds, all those use this technology, although perhaps we don't know it when we use it. And this is why the Royal Society has carried out a major policy project on machine learning. It's been investigating the potential of this technology in the near future and the barriers to safely realizing that potential. Now, speaking to the public has been a big part of that. It's a big part of what the Royal Society does, which is why we've asked you to send in questions, and all the questions I'm going to ask tonight are going to be questions that you've sent in. And to answer them, I'm joined by a panel of some of the world's leading experts in computer science, statistics, robotics, and artificial intelligence ethics. We're also going to get a chance to see just one way in which machine learning is being used and will be implemented in our everyday lives in the not too distant future. So without further ado, let me invite our panel to the stage. I think. There we are. And I'm going to get the panel to introduce themselves and give a brief description of their areas of expertise, one by one. And we'll start.
Thanks,
Peter.
Brian. My name's Peter Donnelly. I'm based at the University of Oxford, where I lead a large research centre of about 400 scientists. We're trying to understand the genetic basis of diseases, why people who have one particular letter at one place in their DNA code are more likely to get heart disease, whereas a different letter at another place in the code might make someone more likely to get arthritis, say. And we're trying to use those insights to understand the diseases better. And once we understand the diseases better, to use that biological knowledge to develop new drug therapies and new treatments for the disease. I'm a little bit unusual in working in genetics in that my background actually is in mathematics and statistics, and in the early years of my research career, my research was statistically based. Statistics has never been a subject that I found it particularly easy to get people excited about. There's an aphorism in our field that statisticians are people who like working with numbers, but don't have the personality skills to become accountants. And it's never been easy or in a succinct way to explain what I do. Many years ago, my then girlfriend, later my wife, did a much better job. I was working in America. I was coming to visit her. She was based in the UK. She mentioned to some of her colleagues that I was visiting, and one of them said, "Well, what does your boyfriend do?" And Sarah obviously thought a little bit about how I'd explained that I use mathematical models to understand evolution. So she paused for a while and then said to her colleague, "He models things." Well, the colleague got rather interested at this point, and the woman said to Sarah, "What does he model?" Sarah thought a bit more and then said, "Genes." He models genes. As you might imagine, when I did arrive and the woman met me, she was rather disappointed, but for a moment it was an interesting area. And in some sense, my work today and our research in Oxford is about modeling genes. It's trying to make sense of the very large amounts of data available in modern genetics. So as you probably know, we each inherit 3 billion letters of DNA code from our mother and another 3 billion letters from our father. And in modern experiments, we can measure those 6 billion bits of information in tens of thousands of people And the challenge is to try and relate that to health outcomes, to what diseases they get and how they suffer and so forth. And those challenges involve statistics, and they involve machine learning and tools that will be the subject of the discussion tonight. And finally, apart from my day job, Brian's mentioned the policy project that the Royal Society are involved in machine learning, and I'm lucky enough to be the chairman of that. Thank you.
So I'm Sabine Howard. I'm an assistant professor at the University of Bristol and the Bristol Robotics Laboratory. I usually say I'm a swarm engineer. I'm fascinated by swarms. If you look at birds and ants, they can do these beautiful complex behaviors. And I take inspiration from these swarms to engineer solutions for real-world applications. So half of my lab does robot swarms, and we have 1,000 coin-sized robots in the lab that we can use to think about how robots might be helpful for environmental monitoring, to monitor animal populations. And the other half of my lab does nanomedicine. How can you control trillions of nanoparticles so that they can be more efficient in cancer treatment? I'm also fascinated by science communication, so I spent the last 10 years helping the robotics community communicate about their work, and I run robohub.org, which is a nonprofit, to do that. And on the machine learning side, well, machine learning is really helpful for me because in the case of swarming, you don't really know how to design individual behaviors, and machine learning can help us figure that out. So I'm part as well of the Royal Society's working group on machine learning.
Hi, I'm John Cockcroft. I'm a computer scientist, reformed physicist from the University of Cambridge, where we work on building large computing systems, networks, cloud computing, which are used by a lot of people to run machine learning algorithms, things like analytics that companies like Google and Facebook and Microsoft and Apple run on all of you, which are the origin of some of the cooler, more recent things, or perhaps not so cool. And so these are things that we built because we were interested in seeing how well we could scale computing systems to tackle really large problems. And we've heard about large problems of DNA analytics or swarming robots. There are plenty of them out there, which you'll hear about some of. There are also some interesting small problems. Nowadays, half of my day job is at a new institute called the Alan Turing Institute, which is a national institute for data science, where I'm rapidly learning machine learning. And one of the goals I have is to make machine learning and AI a democratic process, sort of DIY. One of the roles I could take here as a token geek is that I have around 5,000 science fiction books. And in the back of early science fiction books or magazines, there will be advertisements for growing things and, triffids maybe. But I kind of like the idea of, having an advert that says, you too can grow an AI in your bedroom. And so we'd like to make that something that was very easy to do and understandable what the consequences were. So hopefully I can offer some comments based on that background.
Right. My name is Johanna Bryson. I am a reader or associate professor at the University of Bath. I study artificial intelligence. My first degree was actually psychology, and so my main interest in artificial intelligence is using it for making scientific simulations for understanding human intelligence, animal intelligence, what intelligence is for, what cognition is for. So about half of my PhD students work on that question. The other half work on something called systems AI. So it's about how do you build intelligent systems, how do you make sure they're safe, how do you make sure they're robust, how do you make it easier to build human-like real-time AI. And we mostly had been applying that into computer games, a little bit into robotics, until recently. When I was a PhD, I was working on a humanoid robot at MIT, and I was just one of the many people working on this. But I got interested in why it was that people came up and said, well, it would be unethical to unplug that. And I'd be like, well, it's not plugged in. And they'd say, well, if you did plug it in, it would be unethical to unplug it. And I was like, well, it doesn't work. And they'd like, well, if it worked. I eventually realized that people had no idea why it was that they thought AI was something that they owed an obligation to. And so since the early 90s, I've actually been doing a lot of work in AI ethics, and I think that's one of the reasons I was invited here. I'm one of the few people that has been doing AI and science, social science, human social science, and AI ethics for some time.
So I'm Murray Shanahan. I'm Professor of Cognitive Robotics at Imperial College London, and I've been working in artificial intelligence for about 30 years or so in different flavors of AI. So for about 10, 15 years I was working in what's now called classical, symbolic, or good old-fashioned AI, which was really based around building systems that kind of use language-like representations and reasoning and so on. I got a bit disillusioned with that, and then I moved into thinking about how the brain works, how the biological brain works, and I spent a good 10 years or so thinking about that and trying to build computer models of how brains work, animal and human brains. And then recently, because AI has become very interesting again, really largely thanks to machine learning, and I've been looking at how I can kind of bring all of these things together and in order to create increasingly sophisticated artificial intelligence. And along the way, I had the good fortune to get involved in the making of Ex Machina, and I was the scientific advisor on Ex Machina, and I'm very interested in the cultural responses to artificial intelligence and the implications of AI, social and philosophical implications of AI and where it's going in the future.
Well, thank you. So let's go straight to some of the questions. We've heard two terms there, actually, machine learning and AI, artificial intelligence. The question here from Lisa, which I addressed to Peter first of all, which is, what are the main differences between those two things? So the difference between machine learning and artificial intelligence.
It's a great question, and I think a good place for us to start. And let me start by talking about machine learning. So traditionally, when someone programs a computer, they give the computer a series of instructions. The computer should do this and then do this, and they can foresee various possibilities. So there can be if statements. If this happens, then the computer does this, and if something else happens, it does that. So in that sense, sort of traditional computer programming is about foreseeing what might happen and giving a series of instructions to cope with all of those eventualities. What's different about machine learning is that in machine learning algorithms, the computer programmer doesn't tell the computer how to solve the problem. It tells the computer how to learn the solution to the problem, how to learn its own solution to the problem. So you can think of machine learning algorithms as, and in many cases they are rather like this, as about learning from examples. The program helps the computer to spot features in the examples and to derive its own patterns and rules, and to use those rules to solve the problems based on many, many examples. And one of the reasons there's been a revolution in the last few years in the power of machine learning is because there's so much data. There are so many examples available of certain sorts. So machine learning, as Brian's mentioned, it's already here. Although the term isn't so well known, we interact with machine learning in many different forms already in our day-to-day lives. So email spam filters based on machine learning, systems to detect credit card fraud through unusual patterns of use, typically based on machine learning. When Netflix or a retailer recommend a film or something you might buy to you, that's based on machine learning algorithms which are trying to predict on the basis of what you've done so far, what you might like or might be tempted to buy. When we speak into an Apple phone to Siri or to an Android phone and say, okay, Google, the phone's ability to recognize the words we're using, that's a machine learning algorithm, and it's been enormously successful recently. And when Facebook and other programs tag people in photographs because they recognize that this image looks rather like the person that's called Rebecca in the photograph you posted a week or two ago, again, that's based on machine learning. And a number of those examples, so image recognition and voice recognition, are at the stage where the best machine learning algorithms have comparable, and in some cases, by some metrics, stronger abilities than individual humans. Now, what's typical of all of those examples, the machine learning examples, and it will be true, I think, in the foreseeable future, is that machine learning algorithms are trying to solve very specific and very narrow tasks. Recognize this, work out what this word is, spot an unusual pattern in financial transactions. And if that's artificial intelligence at all, it's what's called narrow artificial intelligence, a very specific task. By artificial intelligence more generally, and I think we'll probably talk more about it, I think we mean a much broader thing. We think of the idea of machines or computers that have cognitive abilities across many different tasks that are comparable to humans. So machine learning, it's great at specific narrow tasks, but it's not yet anywhere near the broad range of tasks that humans can undertake.
Do we, Johanna, sometimes mean more than that with artificial intelligence? Because so the colloquial view would be, as you said, a humanoid robot, or even if people have seen things like Westworld or something like that, these things that are essentially completely multi-purpose in the way that we are.
Right. Well, I actually would have a slightly different definition of, I totally agree on the definition of machine learning, but a slightly different definition of artificial intelligence. But then we'll get to what the question you just asked. About why we think it has to be a human. So one of the things that people mean when they say intelligent is they mean human-like. But we have a lot of words for human-like, so let's forget about that for right now. I like to think of it in a very computer science kind of way, which is, for intelligence for me, and actually psychology is like this too, it's about being able to do the right thing at the right time. And that's assuming the world is changing, so we call that a dynamic world, then it's not always that easy to figure out the right thing to do at the right time. But by that definition, plants are intelligent. So a plant knows how to grow towards the sun. It knows to drop off branches that aren't getting, trees drop branches if they don't get enough light. They grow new leaves and foliage where there is light. So that's a kind of action, but it can't learn to get smarter. So we say that trees aren't cognitive. All right, so what does all that mean to do with intelligence? So I would define intelligence as something that takes actions in the real world. And I would be happy to include like a thermostat that knows how to turn on when it gets too cold, or to turn on the heat when it gets too cold, the air conditioning when it gets too hot. That's like plant-like artificial intelligence, but we've had that for actually centuries. We've had simple machines like called governors that helped us for centuries. When people talk about artificial general intelligence, one of the things they do is they make the mistake of thinking humans are perfectly intelligent and can solve all problems, which we know we can't even necessarily figure out the right person to date. There's all kinds of things we can't do. We can't memorize phone books, whatever. So that doesn't quite make sense. But the other thing is that this assumption that if something was as smart as us, it would want to take over the world like we do. Well, first of all, most people don't actually try to take over the world. Even very smart and some very wealthy people don't necessarily try to take over the world. But secondly, your phone, if those of you who have smartphones, I bet your phone can play chess better than you and it can do better arithmetic than you can. But your phone hasn't even taken over your pocket yet, right? That's not one of the things we build into AI. We don't say take over the world. That's not one of these pieces. So I think that's why there's some confusion. We project into things that, because intelligence is ours, it's ours. But actually, chimpanzees are pretty smart too. We need to be more generous.
Does anyone else have anything to add on those, I suppose, those definitions or descriptions of artificial intelligence and machine learning?
Well, I think so just to kind of expand a little bit on Johanna's definition, a definition of artificial intelligence that I quite like is, or intelligence generally, is the ability to make decisions and achieve goals in a wide variety of environments. And it's actually that ability to do things in a wide variety of environments that's really important to general intelligence. And that's the sense in which a lot of our AI systems today are very special purpose, such as something that the system that's in your self-driving car, well, maybe not your self-driving car, but the one you'll have in a few years, is a very specialist bit of technology. All it can do is drive cars. Even the amazing system that defeated Lee Sedol at the game of Go back in March, all it can do is play Go, whereas humans have a kind of generality in their intelligence. They can make good decisions and achieve goals in an enormous variety of environments, and that's something we don't really know how to put into computers and robots yet.
No, I totally disagree. No,
Well, you think we do know how to do that?
No, I don't think humans are that good at general. We are better than most other species. In fact, primates in general are great generalists, right? So that's why up until 10,000 years ago, the macaques were doing better than we were. There were more macaques than hominids of any kind, the Homo erectus or whatever else. So monkeys are really good. They get into all these different continents. Suddenly, about 10,000 years ago, we got agriculture, we got writing, we got a bunch of urbanization, and then we started taking off. So this general capacity is relatively recent, and it is correlated to intelligence, but I still think individual humans can only learn so much in their lives. So I don't think it's entirely...
You promised to disagree with me. I don't think you really disagree with me. No.
Well, I disagreed with because I still felt like the limit case you were taking was that we're this incredible generalist, but I still think that actually AI can learn as much. We already have, just in the last few months, AI has gotten to the point where it can do better transliteration. That's like if listening to us and typing it down, a computer can do a better job than a human. That's just happened in the last few months. I mean, there's so many things. I don't think that there's a limit. Again, AI is an artifact. It's something we built. And so if we put all these things into one box, it wouldn't turn it into a human.
Peter.
Sorry, John. John.
I was going to take the middle ground here. The thing about machine learning has advanced so far with a large amount of data. AI uses a bunch of machine learning techniques, so there isn't really a distinction, except who's driving. And so when we use machine learning, typically, machine learning tools have been devised for humans to use for final profit, almost literally for final profit. One of the steps that happens when you build an AI is it has a level of intent or autonomy. And it may be a very simple intent that it's been given an address to reach, and it's a self-driving car, or a disease to treat. But it will use a collection of machine learning algorithms that have been trained up on various things to avoid colliding with things or doing the wrong thing. But it's a goal-seeking system, and that is actually an extra step, which has always been around, even from 40 years ago in Sherdlu, or we could go back to ancient history of AI, that somebody says, we want you to solve this problem, not just create a really good model that's better than one, where the machine learning tools have succeeded is curve fitting better than anything previously, faster, more accurately. This is doing that, and then put it in an artifact, which could be a robot, or it could just be a decision support system, and have it make decisions or do things.
There's actually perhaps a related question from Peter, certainly about, I think, this idea that our view of something that's artificially intelligent can be coloured by the human, essentially, or imagining this thing, the more human it gets, the more intelligent it is. It's a question about science fiction, so I'll ask John, because you said you're a science fiction fan. Is our relationship, this long relationship with the concept of AI in science fiction, has that given us a loaded concept of what artificial intelligence is and how it will interact with society?
In a word, yes. This is very problematic, and the way I mentioned science fiction and being a geek is this is very unfortunate that technology is quite often created by people because they're in a culture which says, oh, this is the next technology to build, not because it's the thing we should be putting all our effort into. And I would say that's not entirely fair to the early strong AI community, but certainly the more recent proponents seem to be hell-bent on creating Skynet, as far as I can tell. When you look at the creation of autonomous weapons systems, what else is it? And that's where a lot of the money is. And unfortunately, devoid of an ethical background, which some people can be, or weaker on it, they may run in there. But they're handed these models. Now, having said that, we were also handed very early on some strong ethical positions, and I'm sure many people are aware of Isaac Asimov's 3 laws of robotics, which he revised later on to include a 4th law, or 0th law, actually, if you're a computer scientist, and which was that robots, in other words, artificial autonomous beings that should do the best for society, not just prevent humans from being injured or coming to harm, or indeed each other coming to harm. It's a very extensive exploration through many stories, and this goes back 50 years. It's not recent. And so many people who have read that will come at the world from that perspective. And Asimov was a very interesting person. He was quite deeply religiously educated, wrote commentaries on religious texts, as well as around 5 million words of science. He was a professor, I think, biochemistry at Columbia University in New York. And so when he wrote science fiction, he was informed by both sides, which I think is very rare. And when you look at the bulk of the films and literature, it tends to be dystopic visions rather than an offer of the potential benefits.
There's actually that question about how we might control or manage artificially intelligent systems. Sabine, actually, this is a question asked by Sam, which is, when you build these things, an artificial intelligence, how do you keep track of what the machine's learned? And crucially, how that information is informing its decisions?
So as Peter mentioned, machine learning is all about learning from lots and lots of examples. And this has been around for a long, long time, but the reason we're talking about it now is that we finally have the right amount of data and the right quality of data. We finally have the computational power, and we finally have algorithms that allow us to put this all together. And so the question of how these algorithms work is going to inform what we can see and how this is happening. So let me just give you an example. Let's say you want to create a machine learning algorithm that can take a picture based on a biopsy, and based on that say, is this cancer or not cancer? Well, the way you would train this machine learning algorithm is you would give it the first image, and that's been labeled by an expert as cancer or non-cancer. Your machine learning algorithm would make a guess, because it doesn't know anything, and then it would check, was I right or was I wrong? And it would go back and change what that algorithm has learned so that the next image, maybe it makes a better prediction, the third image, it makes a better prediction, and over time it becomes better and better at making predictions about cancer, not cancer. Now the patient, if the doctor is using this as a tool to say, is this cancer or not, will want to know why was this decision made. And so that's where we want to be able to have a peek at what this machine learning algorithm is doing. And so some machine learning algorithms might tell you, well, the cancer cell on this image is this size and there's this many of them, and so I think there's this probability that this might be a cancerous tumor. Or it might say nothing, essentially, because a lot of the very powerful machine learning algorithms that we have today are black boxes. You might have heard of artificial neural networks. They are inspired from what the brain does, which is lots of connections, lots of neurons, and just like we don't really understand the brain, it's sometimes hard to understand what's happening in these black boxes. But we can do lots of tests, right? We could test this algorithm many, many times, and that might give us confidence that usually it's pretty good at predicting cancer. But I think what we need to remind ourselves of is this is an important question, and we need to really figure out how to approach it, and that's going to depend widely on what type of algorithms we're using.
Yeah, well, yeah, that was a great answer, and I'm not going to even pretend to disagree with you about that. But I will say another part. I will say another part about. Besides that, in safety is also this question about the whole system. So that's what the Skynet scenario. You create it to do one thing. Is it going to suddenly start doing something else? And the thing that we just heard about could maybe, again, if you had a human that could solve cancer, you would think, wow, that human is amazing. They might be scary. They might be going to take over the world. If you have a machine that takes pictures and then says yes or no, that can't take over the world. There's no way it can take over the world. All it has is pictures you've given it, and it doesn't have any arms or legs or anything, right? So what we call that in computer science in general is architecture. So there's an architecture about what the system is capable of knowing and what the system is capable of doing. And so a lot of the fears of AI are really ungrounded because, again, we think it's going to be this general purpose ape like we are that could go and deploy itself somewhere else. It's not the machines that are going to do that. It is possible. So one of the things I do worry about in terms of safety is privacy. So if you can recommend what is the movie you want to watch, and you can recommend what is the book you want to buy, then you can also guess how are you going to vote, all right? And then you can decide whether to try to encourage that person to go to the polls or to stay home. You can tell them, oh, all the parties are the same, don't worry about it, stay home, and then that affects whether or not that person goes and votes. So this is a mechanism of social disruption if people or organizations use it to be, but the machines themselves are not the things to be afraid of because we can build them with limits about what they can do, what they can know.
So I suppose it raises the question, are you suggesting that we shouldn't then try to build generalist AI machines for that reason?
Okay. First of all, again, this goes back to whether or not it is Murray disagree, and I disagree. So the algorithms that they were talking about are very, very generalist, like deep learning. Very, very generalist algorithm you can apply to an awful lot of data if you format the data the correct way. And that's great, it's really useful. Just like, synaptic learning is really useful for brains, and you can use it in like little, sea slugs or something, or you can use it in apes, and that's great, So it's not that I fear generality, it's that I'm saying that maybe I could fear little nanobots that are somehow programmed to construct armies or something like that. But that's really unlikely, and would be really expensive too. It's cheaper to use humans. So it's not the generality that's the concern, but the concern is that while people are standing around thinking that you don't need to be afraid of AI unless it looks like Arnold Schwarzenegger, that we aren't noticing the other ways that we're changing our society, like this issues about losing our privacy and losing our anonymity.
We have a question actually about the nearer future. Perhaps I could ask Peter first. The question is, what might we see machine learning being used for over the next 5 to 10 years? Now, we've given some examples, but if you speculate, let's say in a decade's time.
I think it'll be very, very widespread. In some cases in things we interact with directly, but often behind the scenes as things that go on in our world. So we've had some examples already for healthcare. I think that's one area where machine learning has a huge amount of promise in helping doctors get better at diagnosing particular conditions, choosing the right treatments, potentially even doing operations. We talked about driverless vehicles. I think they'll be part of our lives within 10 years. We haven't talked so much about public services. So there are opportunities for public services using machine learning algorithms to get better at targeting interventions, to try and be better at spotting a child who might be at risk in a particular care situation, or a young adult who might be at risk of reoffending, and amongst the many such that they have to deal with limited resources, to target those rather better. There are examples in New York of New York City Fire Department using machine learning to get better at picking houses or buildings which are in danger of fires, and again targeting interventions, or tailoring services, working out where the real needs are for different public services and tailoring those. And there are lots of changes I think that will happen in business and industry. Machine learning is already a big part of finance, financial trading. We've talked a bit about credit card fraud, also many lending decisions. Machine learning plays a key part in. I think the pharmaceutical industry will use it to get better. They're pretty bad currently, but to get better at developing drugs. Manufacturing will use it. Logistics, so it's already the case that some companies, Amazon's an example, Ocado's another example, use machine learning algorithms to design their warehouses in such a way that they kind of minimize the amount of effort involved in getting filling particular orders. That'll become much more widely used, I think. And finally, academic research. People like myself in genetics, we're trying to solve problems that involve large and complex amounts of data, and I think machine learning will be an increasingly powerful tool for us as well.
I think, Sabine, you described yourself as a swarm engineer, which is presumably that's how these machines can interact with each other. Do you see that being used in the mainstream in the next decade or so?
I think in the mainstream for the next 5-10 years, it's worth reminding yourself that doing machine learning is really hard. I spent a whole PhD solving one simple task in a laboratory setting. And so 5-10 years is a really short time. That was almost 10 years ago when I started my PhD. So what I see for the future are things that are going to be solving specific tasks, things that are very, very narrow in what they can achieve. And the way I like to think about it is if you were to dream in your day-to-day life, what would be helpful for you as a doctor, as a caregiver, as someone who needs this technology to unload some of the burden they have so that they can focus on the things that they're most interested in. So all the tasks that Peter mentioned, I think, are very, very good ones. On the swarm engineering side, I think there are definitely interest in making robots work together, but swarm engineering is still a long way ahead.
Any other contributions to the speculating on the
I'd like to add to the list of sort of applications, personal assistants. So the kind of thing that we've seen just very recently, Amazon's Alexa has become a huge bestseller just over the Christmas period, and of course we already have Siri, Apple Siri, and Google's Assistant, and Cortana, Microsoft. And I think these kinds of personal assistance technology, which are speech, basically involve a speech interface with a computer. I think that's going to become increasingly prevalent, and anybody who's tried out these assistants will pretty quickly realize their shortcomings. They don't really, in any sense at all, understand the things that we refer to in the conversations. So, for example, when I got one of these Amazon Alexas, and I asked it who was the world record holder in the women's marathon, and it came up with the answer of Paula Radcliffe. But then when I said, how fast did she run? It had no idea what was being referred to by she even. And then if you were to go and ask another question such as, how many legs did she have? Then it would have no real clue that you were actually talking about a human being who normally has 2 legs and so on. And so I think what we're going to gradually see is these kinds of personal assistants will have a better understanding of the everyday world. They'll be able to understand the terms that we use in language much better than they do at the moment, and that's, I think, is going to be a big growth area.
There's actually a question here from Jackie. I don't know any people in the audience who are professional personal assistants who might be getting worried about that, but there's a question here, which is any recommendations for tech-proof or AI-proof careers, given that probably won't be the personal assistant.
Plumber, I think. Plumber. Actually, I'm not entirely joking. I think jobs that involve the sort of the physical manipulation of a house where every house is completely different, every plumbing job is completely different, and there are many other manual jobs like that surprisingly I think are the kinds of things that will be among the last to go. And then, of course, there are many creative occupations that will also be among the last to go. I'm sure we've all got our favourite examples. So.
Another set of examples, I think, are careers that in situations where personal interaction is important. So many of the caring professions as well. I think they're not going to be quickly overtaken by machine learning. And it's obvious, but another career that's a good one to be thinking about in an age of machine learning is going into machine learning on computers.
So going back to this thing about artificial general intelligence, it isn't just about throwing every possible learning machine into a box. It's about human likeness is about being an ape and having the physical experience, and we can actually learn a lot about what that is, and we can reproduce that with AI. But I think just to generalize from what you were saying, the most basic things that humans can do of all the models we build is we have a lot of an idea of what it's like to be a human. And so one of the great examples for careers is automatic teller machines. So what happened to bank tellers when you got a machine that you could punch in and then get your money from the machine? Well, initially, you don't need as many tellers per branch anymore because a lot of the easy things are taken care of. But there are actually more bank tellers now than there were before there were ATMs. Why is that? Because every branch is cheaper now, so banks have more branches. And what are the humans doing? They're not, counting notes very much anymore. Instead, the humans are actually working with the other humans who come in and helping and being empathic and understanding their problems and helping channel them towards the right kinds of services, if it's a nice bank. Otherwise, they're upselling.
So many jobs have some kind of utilitarian value but very little enjoyment, so that's a perfect example. I'm replacing that with machine learning, and modest intelligence seems eminently suited. Lots of jobs, professions, I think most of us, have things we really enjoy doing, and there are many other professions. Most of the time on this stage, there are people that play music or act in fictional or even documentary drama, and this is amazing. It is an amazing thing. Those are things I can't see. Why would you replace those in any way? You could, but why would you? But I would just go back to some of my personal experience, which was before I went to study in university. I spent a year in Canada teaching, and I was doing catch-up maths classes for people. And the most enjoyable thing, and I think I was okay at it, was figuring out why somebody didn't understand something, in what way they didn't understand it, and then what was the way that I could figure out with them that they would then understand it. So actually trying to put myself in their shoes and understand the strategy they could use to tackle this problem they were having problems with, which is difficult to do in a class. And so this is the thing where if 80% of people don't have boring jobs, we could all be in that situation in small groups learning more and more things. We would extend the range and scope of human knowledge for every lifetime by factors of maybe 2, 3, 4, 5. I don't know. We don't know. We haven't tried it. But I would suspect that would be a really worthwhile thing to do. In a lifetime, you could learn to play 5 instruments, act in 3 things. Or maybe you'd be tone deaf and be terrible at that, but then you're really good at gardening or sculpting or teaching somebody to do those things too. So I don't see a shortage of things for where if you remove all the mundane utilitarian part of labor, then you leave things that are enjoyable, and then you free up time for doing more of those, which I can't see a reason to make an AI to do. I may be wrong, but call me naive.
I agree with a lot of what's been said. I think machine learning is about doing tasks, not necessarily jobs, so that frees up more time so that we can focus on the aspects that we want to do. Caregivers could spend more time caring, doctors could spend more time with their patients. But there is a need in terms of being future-proof for more engineers, and especially we need more women, and we need more minorities within this field. And so that's something that I think we should be mindful of. But not everyone needs to be a programmer. I think what everyone needs to be is literate in the technology, so that the doctor does see machine learning as something that could make his job easier, so that the caregiver can see something in machine learning that could make their job easier. And so it's this mix between more people who can design the technology and more people who use the technology in a proper way, which hopefully can build up things in a way where we have more time to do the creative side and what we really care about.
I take a double dip, but I want something that John said is very important. This thing about whether or not we have drummers. Okay, so there was artificial intelligence. One of the things I've been saying for decades is that we make a big exception about it. Sometimes there's not that big of an exception. That was already a question when people brought in recorded music, right? How is this putting drummers out of business, right? And this issue about whether or not we have enough money to pay people to come and paint our house. First of all, it's a political decision that we can make when we decide whether to have live music at our wedding or to have a DJ, right? Or whether we want to have custom-made furniture or we want to have factory-made furniture. So this is not something that's being driven by some exterior force. This is decisions that we make as individual consumers. And then there's another issue, which is about how is the economy shaped, whether or not the money is distributed, all going up into just a very few people, very few companies, or whether we apply taxation and redistribution such that we can employ, that more people can afford the capability to hire real drummers for their weddings and to have people come and paint their house by hand and have interesting murals instead of just all have, plain white walls like we do right now. So I want to point out that this is not just about what are evil technologists going to do to us or whatever. This is a decision that we as a collective have to make about what do we want our future to look like.
Yeah, I suppose most of the discussion so far has been focused on these things as very specific tools, I suppose, almost glorified screwdrivers in a way to do specific tasks. But we have a series of questions which I think are pointing to that broader idea of building very intelligent systems. For example, one from Raman, who's asked, what ethics ought to govern the development of artificial intelligence? So perhaps I could ask Murray. I suppose that really is beginning to talk about I suppose sentient machines, ultimately. It's pointing towards perhaps.
Yeah, you can ask those questions, ethical questions about the sort of shorter-term tool type AI as well, and they're probably the more urgent questions to ask. And so sometimes people discuss the possibility of having kind of regulation of AI research, and I always think that that's a somewhat misguided idea. But I think what you can do is you can have regulation and ethics that govern particular application areas of artificial intelligence. So you could look into privacy in the context of personal assistants, for example, which are getting a lot of data about the things that you say to them, and you can imagine all kinds of ethical, regulatory frameworks that govern how that data is used. Similarly, autonomous weapons, you may think about banning them altogether. Might be a very good idea. And so I think that you can think about ethical considerations, one kind of application area at a time in the short term. In the longer term, well, I think possibly some of these questions are alluding to, again, the sort of possibility that we're drawn towards, and we see in science fiction, of something that is very human-like and seems to have kind of consciousness and so on. And I don't see any reason theoretically why it's not possible to build something that has those attributes. But I think if we get to the point where it looks like we are capable of building those things, we should ask ourselves whether we really do want to bring such things into the world, whether that's a good idea or not. Because if we brought something into the world towards which we had some kind of moral duty, then we should think twice about that perhaps.
Does anyone see a fundamental reason why we couldn't, at some point in the future, build a thing that you would say was conscious, something that passes the Turing test or something like that?
Well, there's a difference between saying, okay, so you may not believe this, but remember how I said that intelligent, we thought, intelligent means to be human? Same thing about conscious. There are so many things that we have words about conscious. If you mean by conscious self-aware, then the basic problem computers have is they're too self-aware. They have access to every bit of their memory. That doesn't do them any good, right? Whereas we don't have access to our memory, as we were talking about. Because in computer science terms, that actually there's combinatorial problems with knowing too much. And the whole point of machine learning is sort of generalizing, shrinking all that knowledge down to a representation that can be used in more different situations. So I don't want to talk about consciousness, but to go back to just talking about actually being like a human, like Murray was just talking about. The British are actually ahead of the game. This is something that the UK is one of world leading. We had a policy document 6 years ago now. It was called it's called the EPSRC Principles of Robotics. The EPSRC is the Engineering and Physical Sciences Research Council, so they're the people that the British government used to fund AI research. And it had 5 principles, the first 3 of which are correcting the Asimov's laws. First of all, to make them computationally tractable. So Asimov was not a computer scientist. He had 2 PhDs, and I believe they were indeed in biology and chemistry, but they were not in computer science. So the Asimov's laws were not computationally tractable. It's impossible to see everything you're going to do and what all the consequences of your behavior are. We can't do that. But secondly, more importantly, we were looking at AI as a manufactured artifact, and what do you want when you have a legal commercial product? And we said, look, we want to disrupt the law, the British law, as little as possible. So we think AI just fits into that. We can just say, let's think about AI this way. Let's think about AI as a product, and then let's make the choices to make sure it is a good and safe product. And in that case, making an AI that would suffer, if that's possible, and I think there's real issues with whether you can make an artifact suffer, not because suffering is magic, but because by definition, suffering is something you avoid at all costs, and if you build a safe system, you build a module, you tend to put things into it in a modular sense, And so if you were going to avoid it by all costs, you'd take the module back out again, right? So I think there's a problem with suffering in particular, but most things, it's not that big of an issue. I think I'm going on too long.
Well, I think that, there are two linked questions, perhaps, just very briefly. You started answering this one. It was asked by Adam, which is, perhaps I could ask Sabine and John, do you believe that we need to start building a framework of governance for AI technologies? I suppose, in a sense, we've just heard that we have started.
Yeah.
So do you think it needs more work? Is it sufficient?
I think at this stage what we need is more data, more information about where we're going with machine learning and what we want to use it for. I think standards are wonderful, doing best practice from the point of the government in terms of making data open, explaining why they make decisions is also best practice. And what I really like with what we're doing at the Royal Society is actually asking the public what they think. Because a lot of what we're seeing happen in this year is because the public don't feel they have a say in the way technology is progressing. And so a lot of the discussions that we're having, asking the public what they think, only 9% know what machine learning is. That's a very small percentage. I think is going to help understand how government should build this framework and inform the direction in which machine learning goes in the future.
Is it, Peter, similar to questions of, for example, drug regulation and many areas where there's scientific input required, but there's, or John, but there's a significant element. The scientific advice is one component of a much wider debate that you absolutely have to have in order to build these regulatory frameworks.
I think that there's a missing step there. There is a similarity, but there's a difference, which is, as I mentioned, I think we were kind of on roughly the same page, that AIs incorporate machine learning. If we're just talking about machine learning algorithms are to a more or less extent transparent in how they operate. And some of them create models which are explicit and visible. Some of them could do that if the people that wrote the algorithm would let you see that. So what Facebook used to order their news feed or what Netflix used to recommend to people is not transparent, it's commercial in confidence. But some algorithms are not even amenable to that at the moment. That means that the system is trained on some data, and then the data may be discarded for privacy reasons. And then from then on in, you actually don't know why the system outputs behave the way they do. And this is a kind of new area, I think. I think computer science has led us into a rather weird situation. We could say, well, actually, it's not obvious why people do things the way they do, and you only have to watch the last episode of Sherlock to be struck by this. There are plenty of things. What on earth is that guy doing? And he's the detective. So, however, we're constructing systems, and then we have some kind of responsibility to make them effectively legible. In other words, people can see why they make the decisions, and perhaps give people agency, so power, to have access to them. And in fact, there is a European new law, general data protection regulations just coming in, maybe just in time or not, which actually says you will have the right to have a decision about you by an algorithm explained to you. That doesn't necessarily mean you get to download all of the training data for the neural net and run the neural net again with your data taken out. But somebody has to go figure out what that will mean. And I think that's a sort of level of governance that is not just being explored. I mean, that's quite mature, that somebody's trying to cast that into, has in fact cast it into law right now, without spelling out the technical way it's going to be done in every case. In many cases, it can be done. In many of the older machine learning cases, it can be done quite easily, which is a good thing. So if we want to remove recommendations for things that are essentially unfairly based in race or gender or some other factor that you shouldn't, then we can do that in most machine learning. But there are other systems where it's rather weird. To say this as a computer scientist and part of a team of people who make these things, it's mysterious how they work. We're building a thing, and then we can get into a discussion about making things and being like God, and then not knowing how they work, so they can't be a God.
Well, it's just, we have to just pause because we're going to have a demo in a minute, but I just wanted to bring up something we spoke about just backstage, actually, which you said to me that it can be the case that these algorithms do things that are really rather not only unpredictable, but surprising and unusual.
Yes.
Because we don't fundamentally understand how they're making the decisions.
So the problem with specifically neural nets, which are the sort of deep learning technology of choice and the most effective, is that they do a trick which is seems odd, which is called dimensionality reduction in the way they work, which effectively means they are discarding information because it would appear to be irrelevant. And this maps into physical world problems that we talked about earlier, like image processing or voice recognition, rather well, because the inputs have physical properties that are local. But it means that they're fooled by weird things. So they're classic examples of images which you can feed into a sort of Google image search. You can basically give it a Rorschach diagram and it will find penguins because the algorithm it has will effectively match on random black and white blobs. And that unfortunately is not explainable. It's actually a little bit like humans with optical illusions that we're susceptible to. There are glitches in how we've evolved to detect things. And this is similar, I think, but we don't have obvious ways to fix that. So in the older machine learning things, we have ways to look at the model and it's explicit inside the code. Even a Bayesian inferencing system learns latent variables, and you can go, oh look, it's learned this association between these things we didn't expect that is a medical cause of something. You go, great, well that explains itself. These currently deep learning systems don't quite manage that, but there's a lot of work going on to fix that, so that's a hot topic.
Well, can I give you a positive example of a bit of behavior that's hard to explain? So this is going back to the Alphago program, DeepMind's Alphago program that, excuse me, that defeated Lee Sedol back in March at the game of Go, this extraordinarily complex Eastern game where you place black and white stones on a board. And in one of the games, it played a move that all of the Go masters, these very advanced Go masters, thought was a mistake. Because it's not the kind of move that any human, Go champion or great Go player in history has ever played. And it turned out that this was a masterful move that opened up a whole new kind of way of playing Go, in fact, that they've been very interested to explore since then. And AlphaGo went on to win that game and to defeat Lee Sedol. And that was an example of a kind of creative move from artificial intelligence, which did something extraordinary that humans don't, the programmers didn't understand why or how it did it, and even the masters couldn't explain why it was such a good move.
Right. We're going to just break into the Q&A because we do have a demo, which is a quite spectacular demo about how machine learning can be used. So I'd like to welcome on stage Mirko Kovac. Who's around? Mirko. Very welcome.
He's gone from
Mirko. So Mirko, as you will see, is going to give a brief talk and then demonstrate drone technology.
Okay, thank you very much. In fact, thank you also for the interesting discussion. It really inspires me to think of the future and how the future will look like. In fact, it connects a lot to what I was thinking for the last many years, in fact, on particularly future cities and how intelligent future cities could be like, how your life would be like, how we all come here, how our homes look like. And in fact, if you look about that, there is one vision you see here on the screen, which shows how a future building actually could be an intelligent being, an intelligent system, similar to an organism that would equally have all the capabilities to sense, to interact with humans, where also the drones or drone technology could interact with them, interact with humans, and like this propose an entire ecosystem of systems that would interact and provide us with the well-being and the everyday needs that we have. So this is something that my group at Imperial College is focusing on to develop the flying robots and in general the robotic technology to enable that. So just to give you today 2 examples that I would like to share with you that kind of outline some of those examples, and one of them is this. So the idea here is to really overcome the limitations of drones, which is really the flight time. So you can only fly about 10, 20 minutes. And one approach how to do that and how to reach hard-to-access areas is to go there and perch, so to attach to the structure and stay aloft for much longer time. So here you see the concept of one drone that will go there, build a support net, like a spider net, for the next drone to then collaboratively attach to it and observe the environment for longer durations of time. So you can imagine that this can really extend the duration of sensing or just provide us with the needs that are there that we have, like to sense pollution in cities, to sense different ecological markers, to protect the environment as well. Now, the way how we build that, and that's in a laboratory environment, the drone that you see here is about as big as my palm, so it's a very small drone. But what you see is that autonomous control systems can allow it to build this kind of spider web structures, but also the philosophy behind it is that we look at nature, we look at spiders, and we extract the key principles of how they operate, how they build, how they sense. And in fact, spiders, they sit in their net and even sense the environment through the net that they have built. So they don't just use it for perching, for catching, but also for sensing. And this is one approach that we have developed here on the concept level. Good, so like this, it attaches, it can dangle around, fly out again. Now, another example would then be to use several of drones to build larger spider webs to then catch other drones or even manufacture different environments, make a bridge, for example, and like this, use these tensile elements to build those type of structures as you see here. Now, there's a second project or a second idea that I would like to expose to you today, is to use the same approaches how, for example, nest-building birds use to repair structures, so repair pipelines, for example. This is a build drone concept. So you see there's a pipeline leak, for example, and we have a drone that goes and deposits material like a bird to repair this pipeline leak. Now, we have shown that conceptually here, as you see, would fly and would deposit polyurethane foam, for example, to do that very precisely. So this is a classical control system that is built in here. So it doesn't learn how to do that, but it could do, and learning actually could improve the performance. But also, it could, we need to develop the mechanics to make it better. And so one aspect how to do that, how to make it more precise, because wind might perturb it, for example, we built this small delta arm system, as you see here, that balances the movement of the drone. So there might be wind, there might be inconsistencies in the sensing, sensor drift, for example, and then this delta arm can really balance and stay on the spot. Here again, it's the philosophy of the animals, but it's the best of engineering that we have to build this in. And machine learning is really in between those. It's also looking at nature in some way of how we learn, how humans and animals learn, and then build it into the best, using best of engineering knowledge. Now, we have today with us our artificial agent, which is the build drone. And if you don't mind, I can reveal it for you. So please. So it's one that lives with us in the laboratory. It's our friend. And in fact, in many of those visions, we see them as friendly drones, friendly technologies. And so just to illustrate a bit how this looks like in flight, we hopefully can make it fly. So
given it's your friend, does it have a name?
Yeah, so it's called Build Drone, but I'm not very happy with the name. In fact, if you have a better idea, please tell us. How can we...
Well, all right then. Well, at the risk of it getting called Boaty Mac Boatface, if you want to, you can tweet actually. So there's a hashtag RS Science Matters. So if you want to tweet possible names for this what is it? I was going to say this chap over there. I don't know what to call this thing. But anyway, if you want to tweet, I don't know, for it, then do so. And I don't know whether you'll accept the most... It's going to get called Boaty Mac Boatface.
If it's a nice one, I'll think about it. But we really look for one. We need a very nice name, actually. Bob is not interesting enough, really. So,
yeah. So hashtag RS Science Matters, and we'll look at those so we can find one.
Okay, thank you. Can we try to make it fly? I hope it's in good mood today. Yeah. You never know what it learned, you know. So. Okay, so here you see generally how it does that. So the stability to stay on one spot is done again with a PID controller, for example, so classical control, But even this, on how to balance this, could be learned. So machine learning could be an approach of that. It's in fact something we are looking at and doing for the next generation of this. The other thing that it could do is it could use this delta arm. You see the movement that it can do? So I can move around a bit to see, yeah? Okay. So it could also fly and not just put, like patch, repair. It could also manipulate the environment, like solder things or cut things. And like this really be an extension arm, like an elephant trunk that would go and manipulate the environment and really make a difference in industrial inspection or home maintenance tasks. Okay, thank you. I think. Okay, thank you very much.
So how much, I know that, I should say there's Laura and Pesak over there, actually, Pesak, controlling the drone. So there's some remote control there, of course. How autonomous is that one? And how autonomous could you imagine them becoming?
So this one is autonomous on the control system level, so that things it does are autonomous. But that's one point that I think is very important in the whole discussion is, what is intelligence? So it's not just, like humans are a bit brain-focused, many of them, especially scientists, so including myself, I guess. But it's not just the brain, it's not just the intelligence, it's also the emotional intelligence, the intuitive intelligence, and also the physical intelligence. The physical body has an intelligence built in. So for example, if you have your hands and you press in the middle of your palm, the hand will close passively. So there's no control needed to do that. It's really the mechanics of your hand. And in a similar approach, I have a slide on that, if you don't mind sharing that, is to look at ways how to attach to objects, so how to perch to walls, for example. And if you have a lot of control, a lot of weight, a lot of sensors, like all the way on the right, you can do a complex maneuver to attach. But when you get smaller on the size of insects or very small systems, you cannot afford all the sensing. So you need the physical intelligence. And the thing that you've seen before is this spider-inspired perching, where the string makes the intelligent attachment to the structure. And I think this embodied intelligence is another layer that we have to incorporate in our machine learning approaches and philosophy as well.
Well, it's, does anybody have any questions about that?
I have a slightly rude question.
A slightly
and my
rude
microphone's
question.
been turned off. Oh, there we go. Yeah, I was just wondering, you said the robot was your friend. How many of your friends do you keep under blankets like that?
Like the birds, you also make them sleep at night, right?
Right. Well, yeah, so yeah, we do that with pets and dogs too. We say our dog is our best friend, then we leave it locked in a cage all day. Again, these are issues that will probably come up in the second half of questions.
Yeah.
Yeah.
But depending on its personality, it might get scared when it sees all the people, so that might be...
But you do, I mean, you are referring to your anthropomorphizing, is that the right word? Yes. I mean, how fast do you see these drones? We hear about delivery drones, for example, in particular from Amazon, I think. How soon will it be before it's absolutely commonplace to see drones like this around in our environment, as you showed on that slide?
So if you can go back maybe to the slide, I think a lot of that we are to the vision slide. I think we have one. So there's a lot of this already happening. So drone deliveries are a reality today in Rwanda, for example. There was a large project on delivering medicine, and they are becoming our part of our cities. Lord Norman Foster developed these drone ports as part of a city. So how do they interact? How do drones interact with cars, with humans, with buildings? And I think we need to think of it as an ecosystem. Again, looking at the biology, how biology works and how it has worked for many millions of years. And if we do this right, if we get these interactions right, then we can create a technology that really is the ethical, supportive, symbiotic technology where humans can increase their well-being and the drones and robots taking care of all the things that is dangerous for humans, for example.
Because we talked briefly about the regulatory framework that's been put in place, partly already, but what also needs to be done? I mean, I noticed that we talked earlier, but that one's tied down to a big weight in case it goes crazy and flies out into the audience, injures somebody. So in terms of drone, at the moment, drone flying is quite heavily regulated. So do you work on developing that framework, particularly if I'm thinking of autonomous drones that are not controlled by people?
Yes, and there's a large push in that in different countries. The US in August has released a new framework for drone operation that you can just simply do an online test and sign up to operate your drones. In the UK, there's a similar movement that is happening just now a few weeks ago. A similar initiative was launched. On the EU level, also this happens. So now it's a bit of a drone race of who creates the ecosystem on the economy, regulation, education sectors to really attract all the startups of today in this sector, which are the Airbuses and BA systems of tomorrow. So the question is still open, and it's still small companies, so it comes from the roots, so it's grassroots type of development, a lot of it, but it needs to be worked on, and it needs to support innovation, I think.
So do you think the interaction between government and the public and the research scientists like yourself is adequate at the moment? Does it need to be improved?
I think a lot is already happening, and what is important is to think a bit out of the box of what can be done with drones. So delivery is one thing. It's like a first most obvious step in some way. Photography is another one. But what else could you want to use a drone for? What is your vision? So how would you do it? And I think if we like this all together work on the ideas, on the collaborations, and create this from all of us today and tomorrow and following this the next years, then I think it starts from the right place. So it's on us. It's like a crowdsourcing of ideas initiative that can make a difference in this space. Yeah.
Did anyone ever send out their phone on a drone to play Pokemon Go?
That's a good idea.
Like an obvious thing.
Good idea.
You know, speaking of regulation, one of the thing about regulation is that it's not only about stopping you from doing things, it's also about encouraging, so regulations include things that encourage innovation or whatever. But speaking of such regulations, one of the things Sweden has done is Sweden has said there cannot be cameras on drones because they thought that was the only way they could solve the privacy problem. So it isn't just about scrambling to get the innovation there first. There was actually something about mobile phones. So mobile phones were taken up in Europe much faster than the United States, and the reason is because in Europe, the person you called was charged for you having called them with a mobile phone, right? Even though they didn't know, or if you called someone with a mobile phone. And in America, that was seen as not fair, and so the consequence was people were much faster to buy them because they were cheaper to buy here. But then, you guys had really outrageous costs for your phones for quite a long time until the EU saved the day like a year ago or so with damping down on these cross-country.
Oh yes, so you mean for roaming calls?
Roaming calls were the most recent thing, but yeah. So anyway, that's the I just want to say that we should think about regulation and government as a way that we come to an agreement ourselves about where do we want drones, how much do we want to hear them, how much do we want them flying over our own yards, looking in our own windows. It's something where we can see the positive advantages of drones and we can see the negative consequences, and we can't just individually guess all the consequences, as we were talking about the surprising things earlier. So we have to keep exploring, and we use the government. The government is the way we coordinate our desires. So it's very important that we're invested in trying to make this stuff work.
Yeah, maybe just one example is the Red Flag Act, Do you remember that with cars? When cars were invented, there was a regulation that you have to walk in front of the car holding a red flag. So,
yeah.
Of course, all the innovation happened in France, not in the UK. So I think that's one dynamics that can happen. Now, today is really, I think a lot is about the fear of people, not accepting new developments. Now, is it going to crash or not? Privacy, but a lot of other risks we accept widely, easily. So I think once we overcome this fear, this initial acceptance fear, then it will just bootstrap completely.
So you think that this image, that drones being absolutely part of our environment is going to be the way that it is in, what, a decade, 2 decades or so?
Well, I have no doubt. It will be an integrated system. Everything around us will become more robotic, more autonomous, more sensorial, more interactive. And it will become to the part that we won't call it robot anymore. We won't call it drone. We will call it a jacket or house or car. And that will like mail delivery. You know, so I think this will happen, but we are not there yet. But we need to, I think, keep in mind that there is a future. So 200 years ago, people wouldn't think about iPhones or Android phones or competition between the two. So I think there's a lot more to come.
I suppose it is a very good point, isn't it? Because if you go back 50 years, then we would be having this ethics discussion about mobile phones or cars, as you said, if you go back 100 years or so. So, do you all think that's really, we're having a discussion here that's going to seem arcane or you know, rather quaint in 20 years' time?
Well, as you know, if you took a mobile phone back 500 years, you'd probably be burned at the stake. And not just because there was voices coming in on it, but also because it could do math. Math was something that only humans could do. It's separated from the rest of the world. It was part of the evidence of our divinity, right? So having a machine that did math would have been a big issue. I think that, and this is, again, it's not determined for sure, but I think the most coherent thing to think as is what you said, that it becomes part of the infrastructure. But that isn't to say that we shouldn't be afraid of it. It is an issue that then our clothes, our forks. You can get a fork on the internet. I don't know why, but people sell web forks, right? So do you want to know whether or not your fork is sniffing your passwords, right, and passing them on? One of the problems with the Internet of Things is a lot of these devices are super cheap, and so they aren't going to get upgraded when people find security problems with them. They're just going to say, well, buy another light bulb. And then a lot of people aren't going to buy another light bulb, and then we have all kinds of security holes in our houses. Yeah.
I actually just got one of those today, believe it or not.
The fork or the light bulb?
The light bulb.
Okay.
You can talk into your phone and make the light change colour. It's the most amazing thing. It just arrived this morning. I don't know why.
Yeah.
It's good fun anyway. Well, we should say actually. So thank you very much, Mirko.
Thank you, my pleasure.
And also thank you to Laura and Pisak. Thank you very much. Yeah, it's a very cool thing, the light bulb, actually.
Yeah, it's cool, but there was just, it was ironic. that Princeton had a meeting on the security of the Internet of Things, and it was the exact day that the entire Internet was brought down on the East Coast of America. Not the whole. Google is really good at defending itself, but most of the Internet was brought down. Netflix was brought down. Twitter was brought down by a botnet that was on baby cameras. So, you want to have, of course, you want to have your baby camera on the internet so you can go party and then still look at your phone and see if your baby is still there, right? That's what they buy them for, right? And so, but again, those are unsecured CPUs. I mean, CPUs are so cheap and so easy to make, and people were doing denial of service attacks by making botnets, and it was 2 weeks before the American election, and they took down the internet on the East Coast of the United States.
I wish they'd left it down for moving on.
Yeah, I sort of wonder if it got out a little early, if they had expected that to happen 2 weeks later. But anyway, yeah.
But in the last, we've got about 15 minutes or so left, and I've got a lot of questions to get through. One from Paul, which is related to what we've spoken about, actually. Should we expect a backlash against AI technology developers and companies in a similar way that we currently see against globalization?
So I think it goes back to this question of bringing a benefit to the public. I was recently at a conference in machine learning, and if you looked at the name tags, they were Facebook, Google, Amazon, Uber, Tesla, a lot of the big players, because they're very excited about machine learning now, and they're growing, and they have the 3 components, right? They have the data, they have the computational power, and now increasingly they have the talent, because a lot of researchers are going into industry. And so I think concentrating all that power in the hands of a few people is worrisome to people in the general public. And so what I think needs to be done is to really think carefully about how the benefits can be shared, whether it's monetary benefits, whether it's the services, because they do provide services that we use every day and are a real benefit to us, and whether it's actually making it more open in terms of how they do it. So a lot of them have been really good at sharing their algorithms, which I think we should really applaud them for, and that has the potential to democratize the technology so that the startups, the vibrant startups that are coming up can use that, so that the person who has a bit of data could use that for themselves as well. But it's a tricky thing to do well, and so that's something that people are mindful of right now.
I think it's one of the biggest challenges we have as a society, and I think we need to think hard about it and act quickly, probably, as Joanne mentioned earlier and Sabine's just said. So machine learning algorithms will improve efficiency, at least in the areas where they're good. That's likely to improve productivity. That will probably lead to increases in living standards. So there's a kind of benefit there. There's some increased productivity. And I think the opportunity for us as a society and a challenge for us is to think about how that if you like the productivity dividend of machine learning algorithms, how's that going to be used and how will it be spread? I suspect if we don't do very much, if we're not active, what will happen is that dividend will end up in the hands of a relatively small number of companies and individuals. And the obverse of that is that there will be people whose livelihoods don't exist anymore because they've been replaced. And the kind of trends around globalization that are already much more of an issue than I think at least our politicians had realized until fairly recently, of disaffected people, will just be exacerbated by that. So if we don't do very much, I think that might well happen, and the sort of backlash, Brian, that the questioner foreshadowed may well occur. But as several other panelists have said, it doesn't have to be that way. I think we as a society have the opportunity, if we act quickly and we think hard about it, and we act with some gusto and some courage, we have the opportunity to make sure that productivity dividend is spread, and so that everyone benefits rather than a small number, so that instead of increasing inequality in society, that the benefits of machine learning could in principle, and I think many of us would agree should, but could in principle be used to help society, to help equalize things rather than increase inequality.
Yeah, and actually I think we spoke earlier backstage about you begin to get into political choices, such as, for example, universal incomes, because what you're really talking about, if this works in the way that we're all imagining it could, is you're in the golden scenarios, you give people free time to do creative jobs and not menial tasks.
Could I just jump in really quickly and say exactly what was just described happened at the late 1890s, the early part of the 20th century. So the same thing happened. Then it wasn't AI, then it was oil and things like that, but we had this massive income inequality. It also led to massive political polarization and mayhem, and it led to the world wars, right? So this is a problem we faced before, and exactly what you just said is incredibly important. It isn't something special about AI, it's special about technology in general, that tends to allow for these pilings up. And so we need to figure out how to damp that back down so that people they're just thrashing right now, looking for good solutions because it's not clear, and that's partly because of the way the economy is.
We've been pretty bad as a society in all of the previous opportunities to do things like this, and I think we just need to get better.
And we need to get better fast, because I think the thing about AI is that the advances are happening quite rapidly, so we really need to kind of get on the case.
Yeah, we did solve this once before. We had a period between 1945 and 1978 where we did keep wages pretty much equal to the rate of wage went up with about the rate of productivity. But that was a weird exception. And I think it was probably because people were trying to solve the problem of communism and all this chaos that we'd had in the last 50 years. But we need to get back to making that a priority because that worked. So it's not, you're right, it's moving faster now with digital stuff.
And I think a vital part of the right sort of strategy for this is education, and educating people to basically be very flexible in their careers and very creative as well, creative and innovative. And we need new kinds of people to sort of live in a different kind of way, perhaps. And I think that depends upon education being right.
I just wondering, we've only got about sort of 6 or 7 minutes left, but the last bunch of questions are all quite similar. They're much more speculative, and we've sort of touched on it. So it's beyond this idea that we've got these useful machines that can increase productivity and enhance our lives, hopefully. There is this question of real intelligence, which I know we've touched on, but there's a question here from Angie, which is, how realistic is it that a machine will A, have an agenda, B, be capable of acting on it, and C, act to our detriment? So there are 3 sort of bits there. Perhaps, I don't know who'd like to address that.
Let me have a first go. I think in the short term, as we've heard, machine learning algorithms are very focused on specific tasks, so they're not going to have their own agenda to do something else. There are still challenges there. Those algorithms can, in principle, do harm because the machine learning algorithm is trying to do what you told it to do because of the law of unintended consequences. We've talked a little bit already about the possibility where machine learning algorithms learn by example. There are examples of this in algorithms that have been developed to vet applications for jobs or applications for university courses, where they're given a set of examples where humans have done the looking at a CV and said, yep, go to the interview stage, or no, reject them. And machine learning algorithms spot the patterns and develop that. So humans have implicit biases, some explicit biases, but often implicit biases. And machine learning algorithms, if there are implicit biases in the examples they're learning from, will continue with those biases. And so there are those sorts of harms we need to be careful of. I think there's some hope. There's the possibility, and it's an area of ongoing research, of developing algorithms which are sort of demonstrably fair, where you can say, it's provable that no aspect of a person's ethnic background, for example, is related to the decision that's reached on them. So machines could do better than humans, but again, we need to be careful of them inheriting biases. So they can do harm in those sorts of ways. I don't think in the short term there are issues of them having their own agendas, for example.
There's actually a question which is a more positive take on a very advanced AI. Perhaps ask John. The question from Vicky is, could an AI eventually answer questions about the universe that scientists work their entire lives to solve?
Right.
Could they replace us?
It could be your retirement plan.
Yeah.
And mine too. Yeah, unfortunately, yes. And in fact, we actually are nearer that than some of the other hard AI problems. So computing algorithms, particularly theorem provers, have already coped with Fermat's last theorem and with the 4-color map problem, which defeated humans for hundreds of years. And those are really, really hard mathematical problems, and a large amount of certainly in physics, at the sharp end, incorporates a lot of maths. But also, we have algorithms now that are fairly good at analyzing where the gaps are in our knowledge, which is what science is trying to plug, and then forming hypotheses, which is what you start with usually, not always, and therefore you do an experiment to disprove your hypothesis. Is my quick and dirty take on scientific method. And basically, for a large fraction of sciences that are relatively well cooked, so quite a lot of chemistry, for example, if you want to make a new plastic, you can pretty much turn the handle on this. And I think this is true increasingly where we can mechanize large parts of science right the way through to verifying a whole bunch of the steps. And that's quite scary. But that's the sort of the bad news. The good news is the universe is really, really big, to quote Douglas Adams, and there's an awful lot of difficult problems. And in fact, doing the empirical studies to disprove or prove your hypothesis, not prove, but verify maybe your hypothesis' statistic looks plausible, can involve a really, really long time, and lots of clever people as well. It seems humans do make intuitive leaps, and we haven't quite codified what an intuitive leap is. Somebody could just, could correct me on that, but I think there's a missing step. There are also problems which are computationally intractable. That doesn't mean there aren't solutions. This is a hardcore bit of old computer science due to Alan Turing, but it basically means there may be a solution, but you're not going to find it by one of these automatic means, but you may find it by some weird mix of luck and leaps in the dark and something. And people seem to be better at that. So there is room. But yes, a lot of science can be can be fed through some machinery. Some of that is, in fact, some forms of drudgery. You know, staring at a petri dish, counting the number of green and brown blobs is not fun. But some of it's actually quite fun, even if you spend your whole life and don't solve something. Quite often, also along the way, you come up with some interim things which turn out to be useful for somebody else, which is a sort of another fun bit of science. You know, the things you did that may be a dead end for one person turn out to be the beginning of something else. So I don't think we're there yet. But yeah, AIs are already helping with this a lot, in particular at the more theoretical end of things, where we can actually go through this theorem proving, and I think that's quite advanced now.
There is actually, going back to something you said in there about this, we don't quite know what these intuitive leaps are, these things that we might say are innately human. There is a question by James, which is how far away are we from being able to render, as he puts it, self-consciousness in a machine? And how necessary do the panel consider the task is to develop a true artificial intelligence in
Well, I think we've kind of already answered that before when we were talking. Well, and we may not all agree on that. Maybe we should go around. Yeah. I want to say very quickly about the agenda problem. A driverless car already does set its own agenda. The only thing that we do is say, I want to go to the South Bank Center, and it's meeting all kinds of goals and actualizing all kinds of things. It decides which side streets to go down, all that sort of thing. How is that different from us? Well, maybe humans are a little different. With a lot of other species, the main goal is to make sure that your genes go into the next generation, and then you have a whole lot of side goals that you do to persist that. Humans are a little different because we also want our ideas to go to persist. But I don't know if the point is that because we build these things, we're responsible for them. And as people have said already, we could make the choice to say, okay, we want the machine to choose a random goal for itself, but I don't think we should build a machine like that.
Perhaps good, because there's another question, so perhaps I could go around the panel very briefly. We're running out of time, but this is from Hamish, which is related again. It's what's the panel's opinion on an AI being given emotions and free will? So I suppose the sense is not only can we do it, but would we do it, or should we if we could? Maybe Sabine, you have a...
So I once had a beautiful pink flying robot that I ran into a tree and it broke. So for a moment you're sad and you feel like, oh, poor robot. You do give emotions to robots because we anthropomorphize them, but they don't have emotions, and they don't have free will. And I think we're very, very far from anything that would have emotions or free will. And so part of me thinks that shouldn't be the main question if we're really focusing on what we need to develop in terms of framework, in terms of public discussion, because it's much easier for the public to focus on that question than the real questions that are the more relevant ones in the near term.
I know Murray's got a really good answer to this, so I'll go before you, and then you can do the better one. But I really disagree. All these things, even about intuition, I'm sorry to disagree with some of the people on the panel, but for example, Murray's example from Les Sedol, that you could call that intuition when the Alphago made the jump into a part of the space that no human happened to have wandered before. And that goes back to this combinatorics thing I was trying to explain before. So Go is a more complicated game than chess. But even in chess, if you think of all the possible games, even the short games, not moving back and forth the rook, but a 35-move game of chess, there's more of those than there are, atoms in the universe, right? So combinatorics is gigantic, and so things look like intuition. Absolutely, it's true that there's problems that we can't solve quickly, but the way we solve them is by having 7 billion of us working on them together, and now we're using computers to solve them too. It's called concurrency, and so we are solving all kinds of problems. We're doing things like insight. We can even build things in kind of like emotions. We can build things in that say, okay, good things have been happening, I've accumulated that, okay, I'm going to be excited, I'm going to go out and try to do things. Oh, bad things have been happening, I seem to be damaged, okay, I'm going to be depressed, I'm going to hold back. We can build back synthetic emotions like that, but that doesn't mean we're obligated to it. And I think that this goes back to some of the stuff we said earlier. I think we're obliged to build AI, we're not obliged to. And so things like, for example, we can make it not unique. We can back it up in real time by wireless and make sure that if our drone gets stuck in the tree, then it can burn, it could do whatever it wants. So you don't have to worry about rescuing, do you rescue the child or the last set of Shakespeare or the robot from the burning building, because you figure out the child and Shakespeare thing, you get outside the burning building, and the robot comes up and says, oh, by the way, here's how do you like my new body, and here's the bill from Apple, right? But basically, you've got your brain backed up, right? And so I think there's a lot of things, very simple things we can do to keep AI from being an ethical conundrum.
I wanted to pick up on the self-awareness question. So there are different senses in which we might build an AI or a robot that has a kind of self-awareness. But the problem is that whenever we use that kind of phrase, I think it conjures up the idea of something that like in the Terminator franchise, supposedly Skynet becomes self-aware, and that's when it wants to take over the world and wipe out humanity. So this notion of self-awareness for us seems to bring up ideas of selfishness and the need to kind of like protect yourself and accumulate resources and be greedy. But that's to anthropomorphize artificial intelligence far too much. But there certainly are useful senses of self-awareness that subserve cognition and cognitive capability that we could imagine and we do want to build into computers and robots. So for example, a very simple notion of self-awareness is that the system that controls a robot might be aware in some sense of that robot's body and where it is in space and where the parts of the robot are in relation to each other so that they don't collide with each other and so on. And that's the basis indeed of self-awareness in animals as well, awareness of our own bodies and where we are in space. So that's an important thing you might indeed want to build into your robots and your AI systems that control robots. Then you can build on that, and there's also a sense of self-awareness in which you might want a system that is aware of its own internal reasoning processes and can critique those reasoning processes. So, for example, a machine learning system you might want a meta level of machine learning that learns how to learn by judging how well it's learned in the past and improving on that. So there are these kind of different senses of self-awareness that are very, very important, but we must be careful not to anthropomorphize that concept too much in the context of computers and robots.
Well, sadly, we've run out of time. We're at the final question, which is kind of, in some sense, a trivial question, but it'll be an interesting insight into your views on AI and machine learning, I think. It comes from Laurie, and we're going to ask it to everybody in the panel in turn, so we'll start over there. The question is, which film or television series do you think most accurately depicts the future of AI?
I'm going to give two answers which are both sort of cop-outs. So the first one is the film Iron Man. The reason I chose that is because, those of you who have seen the film, Iron Man has an absolutely fantastic personal assistant. As an aside, Hollywood gives the personal assistant a posh English accent, but in the way it does. And we've already talked about, I think Murray made the point, personal assistants are one area where machine learning and AI will have a big impact relatively soon. Mark Zuckerberg, who you all have heard of, has as a major project making a system a bit like Jarvis, Iron Man's AI. And my other example, because I think it's a great film, is Ex Machina. I really enjoyed it. It's great that Murray was involved. The bit I think that's realistic there is the fact that the guy who builds the extraordinary artificial intelligence starts off by hoovering up effectively all the data that's available in the world. And it really makes the point very well, obviously with great scientific advice, it makes the point very well that data is the key, I think, to success in this field.
Sabine.
I loved Robot and Frank. Who saw it? I love Robot and Frank because the idea is that you have a robot, which is still quite limited, that's there to help an elderly person with dementia stay in their home longer, essentially. And this person is a burglar. And so he very quickly understands the limitation of the technology and somewhat tricks the robot into thinking that it should become its sidekick so that it can go back to its old activities of essentially stealing. And I really like this example because of the limitations. It understands what it's for, and what they create over the film is a partnership that, even though the goal is a little bit dubious, is really the way you'd want technology and humans to work hand in hand.
I would go with humans. I go with humans for several reasons. One is that it is a TV series made here, not Hollywood movie. But two, it depicts a very strong ambiguity about which direction people and replicants, androids, robots, whatever you want to call them, would prefer to go. Some people in it, it's not clear at some point whether they are one or the other, whether they prefer to be which side or the other, and that's a good exploration of the ethics. But absolutely crucially, instead of the artificial beings being lonely AIs, they're social. And humans are social, and the only way you're going to make something that resembles anything like that is to deal with the fact that humans cope with the biggest social net of any of the primates, of Dunbar's number, 150 plus. I mean, people have 1,500 friends on Facebook, and they cope with it because we have language and we can form models of other people's behavior. And that ability is part of not just being self-aware, but being mutually aware. You could have me tell you about a Shakespeare play, and I'd be telling you about Shakespeare, telling you about people who are 5 or 6 degrees of separation from any of us. And that would mean you're understanding why Iago did to Othello what he did, because Shakespeare told me in seeing a play, and I explained the plot to you. I haven't done it very well just now. I could, if you gave me a minute more. I won't, but that's a human capability. If we made an artificial intelligence that did that, it would not be a lonely AI, and it would almost certainly be indistinguishable from us, except in very subtle ways, and we might prefer to be it.
Okay, I'm going to be actually short, but because I'm going to cheat. My favorite book, which is not yet a movie, is Ancillary Justice, and it's a really nice showing of what it is to be in a situation where humans no longer have any privacy whatsoever, and the AI and the humans are interacting. However, it doesn't meet the criteria of the question, because I hope that's not where we go. So I think the best one that is where I actually think is really realistic is a slightly obscure movie called Moon. I don't know if you guys have seen this, but there's a robot in it that absolutely looks like the kind of robot you're going to be stuck with. It's like some crappy thing with writing on it and yellow stickies and whatever. And its emotional interface is like this face. It does like 3 pictures. It's like 3 smiley faces it can do. Like it can look concerned, or it can smile, or it can be neutral. And yet, you get incredibly attached to it, and you recognize that its entire program is to protect the people. And so even though you know it's a machine, and you know it's a simple machine, and there's not much complicated going on, you can still love it, and it still has a huge impact on the plot of the movie. So I think that's sort of the right future and quite accurate.
Yeah, I think a lot of the AI that we see in science fiction is necessarily very futuristic, and that's what that's the role it takes in the movies typically. So I don't think much of it. We don't really know what the AI in 50 years' time is really going to be like. So to say what's realistic and not, I wouldn't like to say. But I can certainly say which movies I think are the favourites. Of course, Ex Machina is a favourite because, and I do particularly like the films that I think raise the largest philosophical questions, and I think Ex Machina does a very good job of that in relation to consciousness and intelligence and so on, of course. And it also is a British film, by the way, I should add, not a Hollywood one. But if I can move away from my own personal interest, then I love Ghost in the Shell, actually. Ghost in the Shell, the manga or the anime, the 2 anime films of Ghost in the Shell, I think were wonderful. I love the whole cyberpunk feel of those films, and they also raised a lot of really deep philosophical questions about consciousness and memory and so on. And it'll be very interesting to see what the live-action version is going to be like, which should be released this year.
Well, look, thank you very much. I apologise, we've gone 10 minutes over, but I'm sure you'd like to thank the panel again. A fascinating discussion. So Peter, Johanna, John, Sabine and Murray. And just very quickly, I'd also like to thank Mirko and the Imperial Robotics Group for the drone and the wonderful presentation. The Royal Society and the South Bank Centre, and I should say also that this whole thing has been filmed. It was streamed live, but it's going to be available forever on the Royal Society website and on the Royal Society YouTube page, so you can go back and watch it all again if you want. And thank you all for coming and for your excellent questions. Thank you very much. Good night. Thank you.